Welcome back to Earth Science. Today we're going to talk about the different types of fossils and how fossils form. So, first question, how do fossils form? Well, fossils are found in rocks like limestone, sandstone, and shale. But fossils can't just be anything that dies doesn't just turn into a fossil, right? It's actually 99.99% of things that die don't become fossils. Only very, 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 very few select few things become fossils, and that's because you need very special conditions in order to become a fossil. Number one, you need to be protected by scavengers. So if you die and things eat you up and then they clean up your bones, you will not become a fossil. Um, you must be protected from bacteria or microorganisms. Well, what those are things that eat up your dead body, right? So still scavengers. You got to be protected from getting eaten. Number three, you must have hard parts like teeth and bones. Soft tissue does become fossil very, very, very rarely in some very unique cases like ice, getting frozen in ice like Captain America, or if you fall into a tar pit. Um, you also need to be near water so you get buried fast because what water does is it moves earth around and it starts burying things around it. So kind of like these conditions, right? Why do you think we have so many shark teeth fossils? Well, it's because shark teeth are actually in perfect conditions to be fossilized. Um, so shark there's lots of sharks, right, towards the bottom in the ocean, and sharks have several teeth and they fall out constantly. That's and they're in water, so when the teeth fall out, they get stuck they fall down to the bottom, and the water starts burying it. So those are perfect. Those are really great conditions. So that's why we have so many shark teeth, because we have a lot of them, right? The majority don't become fossils, but we have so many that even though the majority don't become fossils, we still have so many that do become fossils, even though it's only 0.01% of the things that become fossils. Um, and the reason why water does bury things so well is like, have you ever been to the beach and you put your sand right by the coast and then the water goes out and comes in, goes out and comes in? Well, what the water is doing is it's pushing sand out and it's pulling sand in, and it's pushing sand out and it's pulling sand in. And the whole time, if you're standing there, your feet get buried deeper and deeper and deeper. That's pretty much the whole idea behind why you need water, a water source, in order to become a fossil. Petrification. So one type of fossil are petrified remains. So these are when minerals replace the original material. So these fossils aren't actually what they originally were. Like if you have the petrified tree, right, which we've all seen before, and if you felt it, it feels like a rock. Well, that's because it is a rock, right? What happened was the tree died, it got buried very deep, and then the wood decayed and left this void. Well, within the void, then rocks started coming in, filling that void, and then the stuff material came in and filled the void. The material that filled in the void, which was a tree, the shape of a tree, hardened, and now you have this petrified tree. Molds and casts, it's kind of what I just explained, right? A mold is when something gets buried and decays, you're left with this little impression, right, like a mold. Now this doesn't have to be underground. Molds can be like a dinosaur stepped in mud, right? And that mud hardened, and we still have that footprint, um, stuff like that. And then a cast is when you have that mold and it gets filled in with the material. The cast is what the shape of the mold was, right? So here's an example. Here's a mold, right, of this fossil, and then this is actually a cast. So this stuff filled in that mold and it hardened in the shape of what this fossil actually was. So this would be a mold and this would be a cast of the same fossil. Amber, something that we're all familiar with fossils, is amber. Leaves can get stuck in amber, insects can get stuck in amber. Um, And when the sap hardens, it preserves those insects. It preserves what's inside because yes, it's buried, right? It's buried inside this very thick, um, gooey thing, right? And until we can find, like, unless you lay down in this huge pool of amber, and drown yourself, you're not going to be fossilized in amber. So this is typically just reserved for insects and tree parts. And mummification, right? This is the Egyptians did this. They mummified their people. Well, what mummification is it happens in very, very hot deserts or very, very cold deserts. The reason for this is because the organism, it needs to just dry out, right? Once it dries out, it's harder for it to decay, and the you're able to preserve the majority of the body. But it has to happen under other very, very um, serious conditions as well. For example, lack of oxygen has to be there. If oxygen, what it does, it corrodes things, it decays things. So lack of oxygen should also be part of that. Ice and tar. So these are some of the most well-preserved fossils. They preserve things almost like fully intact. We have a woolly mammoth, woolly mammoths that were preserved in fossil or in ice. We have these. These are actual woolly mammoth hairs. This is a saber-toothed tiger that was preserved in a tar pit in California. Yeah, so we can have really nice looking fossils from ice and tar pits, and that's stuff that it's the actual tissue. It's not replaced by other minerals. And then you have carbonaceous fossils. What these are is it's residue, right? A lot of the gases got pushed out and the liquids got pushed out of the stuff, and you're left with this very thin residue. Um, I remember because it looks like a little carbon imprint, right? Like a carbon copy. So carbonaceous fossils. It typically happens with plants. And then we have index fossils, which we've talked about, these trilobites. The reason why index fossils are so useful is because they help date other things that are around them, because the index fossils are typically animals that have only been alive for a small period of time. So if you find this animal next to another fossil, then you know that that fossil can only be a very specific time, alive during a very specific time range. Yeah, and these are trilobites. So let's see if we can name some of these fossils. So here's 1, 2, 3, 4, 5, 6 fossils. So let's try to name them. 1, 2, 3, 4, 5, 6. Number 1, it's petrified remains. So I want you to pause the video and try these. I should have said this before, but pause the video and try these out. I'm just going to move on though. Number 2, this is carbonaceous. Right. Number 3, this one you guys should get quick. It is amber fossils, or insects that are preserved in amber. Number 4, it is, based on everything we talked about and not these ones, it is a cast. Number 5 is a mold. And number 6, I actually didn't talk about. So I mean, I talked about it, I didn't name it though. So if you have a dinosaur that leaves a footprint, right, and it keeps walking, when you find that footprint, you know that it's you know that that it's evidence that a dinosaur exists, because what else could have left a dinosaur footprint, right? That's trace evidence for the dinosaur. So that's why we call these trace fossils, right? Because they're traces that life existed, even though they're not fossils of actual life themselves. And that is it for today when we talked about what fossilization is, how it happens, and what types of fossils you're going to see.